Students, in this topic, we are going to study about series and parallel grouping of capacitors. Initially, we are going to consider the series grouping of three capacitors of capacitance C1, C2 and C3. In series combination, the second plate of the first capacitor is connected to the first plate of the second and second plate of the second capacitor to the first plate of the third and so on. Moreover, remember that in series grouping, the charge on the plates of each capacitor remains same, but the voltage is divided. Here we have connected three capacitors of capacitance C1, C2 and C3 across a source of V volt. The charge on the plates of capacitor will be same, that is Q, but the potential difference is V1, V2 and V3. So we can write V1 is equal to V1 plus V2 plus V3, or V is equal to Q upon C1 plus Q upon C2 plus Q upon C3, or we can say Q 1 upon C1 plus 1 upon C2 plus 1 upon C3. If we say C is the equivalent capacitance, then V upon Q is equal to 1 upon C. Compare the two equations, the 3 and 4, you will find that 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. In case of parallel grouping, one plate of each capacitor is connected to one point and the second plate is connected to other point. In parallel grouping of capacitors, the potential difference across each capacitor remains same. Here charge is divided, so we can write Q is equal to Q1 plus Q2 plus Q3. Q1, Q2 and Q3 are the magnitude of the charge on the three capacitors. Q is equal to C1V plus C2V plus C3V. If we say that C is the equivalent capacitance in parallel grouping, then Q is equal to CV. Again we compare the two equations and we find that C is equal to C1 plus C2 plus C3.